Good afternoon. Welcome all to Mitre's second instance of our Grand Challenge Power Hour. For the next 2 hours, we will be speaking on the topic of 6G and the future of the internet. And for those that are new to the event, this is a series we're holding monthly here at Mitre, looking at major challenges in the science and technology landscape and sort of exploring the intersections between technology, policy, business, and really looking at how we can come up with constructive solutions for some of these big problems. So I am honored to be joined for our opening remarks here. My name is Charles Clancy. I'm the Senior Vice President and General Manager of Mitre Labs here at the Mitre Corporation. And for our opening segment, myself and Vint Cerf will be discussing these topics with the help of our moderator, Rachel Azafrani. And the discussion here is going to be a range of different topics. We've got about 45 minutes of dialogue, and then we're going to transition to a panel session moderated by Nadia Schadlow, looking at sort of diving deeper on this range of topics. So with that, let's go ahead and get started.
Wonderful. Thanks so much, Charles. Hello, everyone. Good afternoon, and thank you for joining us. We're hoping that this will be an exciting discussion and want to do something a little bit different. And so instead of holding Q&A at the very end, I really would like to invite the audience to pose questions in the chat throughout the discussion so I can work those into this discussion about the future of the internet. We're going to be exploring different scenarios in a few thematic areas. And for our first theme, we're going to start with connectivity. And I'd like to start with a little bit of a premise here. The nature and availability of connectivity has evolved significantly over the last few decades, although has plenty of ground to cover. Even with around 59% of the world's population using the internet at the end of 2020, there is really still markedly distinct access and network coverage globally among urban and rural areas, disparities among a gender gap in using the internet. And so I'd like to pose a first question about connectivity. What technologies will be key to enabling connectivity over the next 10 years, and what are some of their ramifications?
And are you looking for an answer from Charles or from me?
Go ahead. Why don't we start with you, Vint?
I'm happy to jump in. I'm Vint Cerf. I'm Vice President and Chief Internet Evangelist at Google since 2005 and one of the original co-inventors of the internet. So the connectivity is wide open now. In addition to rapid undersea cable development, much more undersea cable than I ever anticipated, linking the continents together. We're also seeing rapid evolution of mobile access to the network, which really took off in terms of utility around 2007 with the arrival of the iPhone and the ability to reach the internet from things you have in your purse or your pocket. Since that time, of course, the mobile technology has evolved from 2G to 3G to 4G to 5G and whatever the heck 6G is. And the two issues there, one of them is that you require towers and things like that in order to make use of these mobile technologies. So concurrent with that, we're also seeing increasing influx of Wi-Fi, notably in establishments, retail establishments, coffee shops and things like that, McDonald's and so on, which give people more or less continuous access. However, that's only true in urban and suburban areas. In the rural parts of the world, internet is much less available. And that problem is being addressed with low Earth orbiting satellites. Since, I would say about 10 years ago, we started to see some medium orbit satellites like the O3b system, which is at about 8,000 kilometers, which was actually pretty good. It's capable of delivering 400 megabits a second from the 8,000 kilometer orbit with about a 50 millisecond delay. But the low Earth orbit satellites, like the Starlink, for example, and the several others, Cooper and so on, and OneWeb, are all in the 700 to 1,100 kilometer range. So you have much lower latency and higher signal to noise ratio and potentially significant bandwidths. The information that I have for the Starlink program coming out of SpaceX is that a reliable 300 megabits per second channel seems to be feasible. If Elon manages to get all 24,000 satellites up, in theory, it'll be impossible to avoid internet access because these things, some of them will even be in polar orbit. So even if you're at the North or the South Pole, you can't claim that you can't do your homework. The interesting question, of course, will be economic. And how much will it cost, and will it be sustainable? I think the SpaceX guys have a very interesting dynamic going for them. When they get the 24,000th satellite up, the earliest ones will be falling out of the sky, and they'll be launching more rockets to put more satellites up. And so it's a self-sustaining business. It's quite a fascinating business model. So I'm very excited about those technologies. I think as we move into the 5G space, something, Charles, you and I might want to talk about, the interfaces to 5G and 6G are quite different from the interfaces that are available in 4G, and they have some implications for the way in which the service is presented to users or to implementers of applications. So let me stop there because I'm sure Charles has much to say on this topic, and then we can perhaps discuss implications.
Yeah, no, and as much as we're not quite sure what 6G looks like, it's kind of already time to start thinking about it, right? If you look at the pipeline of technology, particularly in the cellular space, it takes about a decade to do the R&D, and then another decade to really figure out the standards and the use cases and the systems engineering and actually build the systems, right? And then at that point, you're ready to start deploying these networks. And so essentially, if you look at every decade as a new generation of mobile technology, 2020 is really the rollout of 5G. We're not going to see 6G until 2030, but it's going to be based on research that's happening today at our universities and standards that we need to start thinking about and requirements we need to start thinking about. And it's really interesting if you extrapolate. So usually when you look at the next generation of mobile technology, you start with what are the sort of the key performance indicators, which are at the simplest level, the data rates that you can sustain and the latencies that you see through the network, how long it takes data to traverse the network. And so 5G is taking us up to gigabit per second speeds. 6G probably will be 5 to 10 gigabit per second data rates. Accomplishing that requires us to bend some laws of physics around spectral efficiency, around instantaneous bandwidth of signals. But we'll have to see how to bend the laws of physics to get there. The next is in latency, right? So you see in 4G, we had latencies in the 50 to 100 milliseconds, which were perfectly fine for voice communication. In 5G, we're trying to get down in the 1 to 10 millisecond range, which is what's necessary for sort of industrial automation, industrial control kinds of applications. But again, if you want to improve that by another order of magnitude, in 6G, we're looking at I don't know, 200 microsecond sort of latencies, which again, even if you're looking at the speed of light, it means that your speed of light becomes a barrier to the latency in your cellular network. And you need data centers and compute that are literally within 20 kilometers of the cell tower, or there's just no way for the data to get there and back fast enough, even if you have no other delays in the network. So if you think about this again, it leads you on an interesting trajectory of the really hard research problems that need to be solved as we really think about that next epoch of technology.
So, Charles, I wonder if I can jump in now and react to a couple of things. The first one is that any kind of bandwidth of the sort that you're talking about requires you to be up in much higher frequencies. And the side effect of that typically is that you need to have towers that are closer together, which implies that they need to be bound together somehow, either by point-to-point lasers or fiber. So there's a significant potential cost of moving into those more dense configurations. And of course, it gets worse as you move out into the rural parts of the country. Trying to pursue that kind of connectivity that way could turn out to be especially expensive. To say nothing of the cost of the access to the frequency in the first place. So the huge amount of money, over $100 billion, has been spent just in the last auction. And it raises questions about is there any money left to actually pay for the rest of the infrastructure? The implication of running at higher frequencies is that you may be able to use MIMO, for example, more effectively because the physical size of the transceivers is smaller and smaller at those frequencies. So that might be helpful. I know that we have Milo Medin, who's going to be on the panel. He has a lot to say about some of these things. So I'm looking forward to hearing from him as well.
Yeah, I think if you look at 5G, there's 100 megahertz channel bandwidths in low and mid band. And then up at millimeter wave, we're talking about 400 megahertz channel bandwidths is what the specification implies. I mean, if we want to start hitting those data rates, we need probably a 50% increase in spectral efficiency, which is going to be MIMO. That's the dimension we can squeeze more efficiency out of. But then, yeah, you need 1 gigahertz wide channel bandwidths in order to be able to do this. So that's either carrier aggregation, which we have today in 4G, but in millimeter wave, or it's something new. I mean, again, it's going to drive the design of transceiver technologies that need to have like linearity across these massive bandwidths.
Well, so Ted Rappaport up at NYU is running in the 60 to 125 gigahertz range tests and experiments to see what's possible there. And that certainly gives you plenty of percentage bandwidth in order to achieve those data rates. Rachel, I'm sorry, we seem to cut you off, so why don't you go ahead?
Not at all. I thought there was a good question in the chat that actually, touched on some of these challenges and the implication for position navigation and timing. And I was wondering if we might work that into some of these challenges with tower clusters in space, what might be required, and some challenges that 6G would pose to PNT.
I don't think you need a tower cluster in space exactly. I think we've already experimented with stratospheric 4G with the Loon project, which has been shut down recently. But at least the feasibility of doing that in the stratosphere was demonstrated. I think that I think I'm not good enough on the navigation and timing sector to be very responsive to that question. Charles, are you more knowledgeable than I am about that?
Well, I mean, right now GPS is our standard for position navigation timing. At least here in the U.S., you've got a whole range of different constellations up there. But the design specification for them that's really based on the precision of you have to the satellites have to know with high precision when and where they are, and so that's being driven by chip scale atomic clocks. You've got detailed ephemeris data about the satellite locations. All of that adds noise, right? And so you get down to sort of these 10 nanosecond level timing accuracies, and with a lot of extra effort down to like 1 to 10 meter localization resolutions. But to go, even if you invented a better chip scale atomic clock, you still have noise in the ionosphere that causes basically the inability to be more precise than that. So I don't know that there's anything we can do with GPS that's going to give us orders of magnitude improvements in location and timing without much better knowledge of and real-time knowledge of, say, how our ionosphere is working. But I think as we look at dense deployment of, say, 6G towers on the ground, they themselves can be a source of localization because they know with more precision when and where they are and can be used for more fine-grained localization. But again, as long as they can't be relying exclusively on GPS for that gold standard knowledge.
So, there is an interesting issue here with regard to the need for timing, because the 4G systems and the 5G systems schedule access to the channel by telling the mobiles when they are permitted to transmit, which is quite different from, say, Wi-Fi. So accuracy of time is very important. You could supply the time from the tower, presumably, and you could also supply the tower with time over optical channels, on the fiber-based system, and have atomic clocks built in into the network, as opposed to relying on the GPS. You still have the problem. So anyway, I mean, I think there may be ways of delivering time to mobile units in addition to GPS, which is a very weak signal, as everybody knows, and it's easy to jam, and that is a cause for some concern.
We've got one more question here about implications before we maybe move on to our geopolitical theme next. But this is something I believe you touched on, Vin, a little earlier in the discussion about power, with current costs being driven higher by electricity costs. How much will staying green play a role in this connectivity transformation? And are there fundamental limits around power that need to be bent to continue to increase frequency and bandwidth the rate we are?
Well, that's an interesting question. I think several things are happening all at the same time. The first one is the chipsets are getting lower and lower power chipsets are becoming available. You still have transmission power to worry about, but with the towers closer and closer together, transmit power is actually less an issue. And in fact, what you want to do is to control how much power you use in order to avoid interference. So that plus improvements in battery technology, which are coming partly because of electric vehicles, could turn out to be a relatively solvable problem.
Fantastic. So with that, going to our next sort of thematic topic here about geopolitics and the future of internet governance. And to preface this part, the division over the future of internet protocols could really transform the structure of the internet as we know it today. There are some experts that predict a bifurcation of the internet, or sometimes termed the splinternet, that might result in a separate China-led and US-led different internets, emerging in the context of a broader set of US-China relations development that is now being termed the digital Iron Curtain. Russia and Iran have also been moving forward with their projects to build domestic internets. So question here is, what future internet structures could realistically come from competition between IPv6 and China's new IP proposal, or the success of domestic internets more broadly? And I'll go ahead and maybe ask Charles to comment on that one first.
Sure. I mean, there's a lot there, right? So I think there's the notion of splinter nets or bifurcation or fragmentation is sort of happening for different reasons at different levels of the stack. So you have, I think, lots of bifurcation is happening at the, let's say, layer 7 or the services offered by the internet, where you see region-specific social media platforms, for example. And it's really about catering to the sort of the culture and needs of local populations. I think we've seen China really amp that up to the next level, particularly with some of their social media platforms that, again, much like the US's tech giant platforms, are seeking to be as all-inclusive and cover as many facets of your needs as possible. So you've got the sort of the WeChats and sort of the Alibaba infrastructure of China sort of stacked up against the Googles and the Facebooks and the Twitters of the West. But you see that same pattern happening now at other layers, right? So there's now sort of a tug of war happening over the basic internetworking layer of the internet, not just sort of the services and application layer, with efforts from China to promote an alternative standard for the internet protocol, which is the basic protocol that wires the whole internet together. And to a certain extent, things like the Great Firewall of China have already sort of created some discontinuities in the internet, really more at the application layer with sort of content filtering. But if China is successful with new IP, that represents now a split at the internet networking layer. And I'm sure, as Vint will remind us, that was critical to really cohering the internet in the first place, was having a common network protocol that worked agnostic to the underlying connectivity technologies and was agnostic to the higher level application technologies. And then, of course, at the lower layers, again, we still see market forces primarily driving to common standards, right? It's not as though there's a separate 5G we're seeing in China or in the EU. In fact, we've seen consolidation. Back, if you'll recall, in the 2G and 3G days, we had competing wireless standards, say between CDMA and GSM. When we got to 4G, basically we saw that all combined together with long-term evolution, or LTE. Same thing with 5G. But again, there's concern that we may be on a future path to divergence at the underlying connectivity level if the sort of the fights in the standards bodies continue to really take a geopolitical view instead of a best technology view.
So let's see. First of all, the new IP turned out to be a dud. It made no sense technically. It was briefed at the Internet Research Task Force and the Internet Engineering Task Force. It was a portion, the Internet Research Task Force offered to host some of the discussions that the Chinese were asking for, but not all of them because they thought some of them were outside of the remit of IRTF, and the Chinese delegation decided that was rejection and went to the ITU. So as near as I can tell, the new IP thing is not technically sound. It is simply an attempt to move the discussion about internet over into a different venue, and which I think isn't helpful. So my view is we should stick with the IETF for further evolution of IP, including IPv6, which is still only about, on average, 30% penetrant. I would like to see IPv6 only capable software running so that we can be reassured that when we are all forced into IPv6, it'll all work. The US government has taken the view that IPv6 is important and should be in place by 2025. We've been pushing since 1996, so it's taken a long time, but it's the only avenue forward in terms of having larger address space. I think the Chinese and the Russians and the others would shoot themselves in the foot by trying to isolate themselves from the rest of the internet for the simple reason that if you want to do e-commerce, you're going to have to be able to compatibly exchange information with everyone else in the world. And so even if you decide to build penetrable firewalls, that is, or porous firewalls, which is what the Chinese have done, I don't think that they will be well served by being totally incompatible. My guess is that that there will continue to be compatible internet everywhere, except that there will be attempts to filter at various layers in the architecture, as Charles has implied, whether it's attempts to interfere with the domain name system or interfere with the border gateway protocols. And those various systems, these are core to the internet's operation, are being reinforced now with cryptography, strong authentication, digital signatures, and other things in order to prevent them from being subverted from their primary function, which is to keep the internet uniformly interconnected.
Thank you. I would like to.
Oh, sorry. I was going to ask Vint a question here. You talk about e-commerce as the glue. I've often heard this argument. It's the thing that's going to keep the internet from fracturing entirely. How do you see the pullback from globalization based on sort of anxiety over supply chains exacerbated by COVID-19? Or do you see a shift to more local supply chains reducing e-commerce as the biggest driver there, or you still think it's going to be so dominant that it drive us together?
Good question. First of all, I think supply chain resilience is absolutely an issue. We've learned a big lesson from the pandemic, and I think there will be a great deal of attention paid to building more resilient supply chains, including domestic and local ones. However, any one nation's economy is relative to the world economy small, although certainly the US and Chinese economies are significant portions of the global economy. But nonetheless, if you're interested in maintaining a healthy economic growth, you need to speak to global markets. And the only way to do that increasingly is to be online and be available and accessible and discoverable in the internet. So I don't imagine, for example, that there would be any appetite at all for building two distinct and separate networks, one for the Chinese that everybody has to connect to, and one for the US and one for the Europeans. That would take us back to 1910, when the telephone network was not a single network. It was many different networks, and if you wanted to communicate with someone using a telephone, you might have a dozen telephones on your desk, and you have to know which service did your correspondent go to so you knew which telephone to pick up the call. And it was the roll-up by Theodore Vail that undid that fragmentation. And I believe that in spite of the interference that we're likely to see, and already are seeing, especially in China, but Russia and Iran and elsewhere, to interfere with data flows that are unimpeded, I think that we will not end up with a completely bifurcated network because it's not in anyone's interest to do that.
Thank you. I'd also like to note that there are a number of other people that have joined since we first started the discussion, and that the audience is welcome to jump in and ask questions in the chat here so we can ask them live. There is one that we have here about the implications of Chinese ownership of a large, relatively percentage-wise portion of undersea fiber optic cable and how that might impact internet divergence.
My first reaction is that the cost of building undersea cable is dropping over time, has been dropping over time. The consequence of that is that we're seeing more and more cables being built. So if you don't want to be on one that might put you at risk because of the Chinese ownership or relationships, you may be able to find another cable to use. Google has found itself building its own cables now in order to interconnect its data centers together and not even having to partner with others in order to afford the cost of the undersea cable. So my sense here is that that's not likely to be a major issue. But Charles, do you have a different perspective on that?
I think it depends on how we formulate policy around this, right? So the State Department had come out with a series of recommendations around the Clean Networks Initiative, right? So this was the tail end of the last administration. And it included things like explicitly barring cable landings from Chinese-owned sort of undersea cables on the West Coast. And I'm not quite sure how to enforce that, given the number of cables that already exist so far. There was also rules in there that barred sort of what appeared to bar peering relationships between Chinese ISPs and US ISPs. But again, not sure how to enforce that. Certainly, we haven't seen that come to pass. I think Lumen is still peering a massive amount of backbone traffic with China Telecom. So I don't know. I think it becomes an issue if we have blunt policy that is crafted around it, but not otherwise.
Well, unimplementable policy is generally a bad idea.
That is true. So moving on to our next theme and final theme here, talking about the economic and pragmatic implications of the future of the internet. So to preface this, enabling dramatic increases in connectivity and meeting increased expectations for speed and bandwidth and latency and at the right price necessitates harnessing economies of scale. Hyperscalers status technology companies are making inroads into the telecom sector with their own internet services, their own network infrastructure projects, which are challenging traditional ISPs and cable and satellite providers. So what could the progression of hyperscalers toward becoming tier one ISPs mean for the topology of the internet? And I'll pose this one to Vint first.
So several things are happening, and it's an interesting phenomenon. There is an economy of scale that's associated with cloud computing. And so you're seeing Google and Amazon and Azure at Microsoft building substantial networks that link the data centers together. And that's done for efficiency reasons. Also, it's done because the amount of data that moves back and forth between the data centers exceeds the amount of traffic that is in the public internet. So at least speaking for Google, we've been forced to build these large-scale networks in order to link the data centers together, partly to replicate data to make sure that it doesn't get lost even if a whole data center goes away. But at the same time, in order to reduce latency for service to users, a lot of the data centers are connected by yet another network into the public network, into the ISPs that serve the customers directly. And so that interconnection, which I think is a phenomenon showing up in all of the companies that offer cloud services, has the effect essentially of interconnecting the data centers networks almost directly with the local access networks so that the services can be delivered very quickly to consumers. You'll see similar kinds of behaviors or mechanisms showing up with content distribution systems like Akamai that are placing their facilities close to or even in the central offices and the like of the telcos and the cable cos, again, to reduce the latency and reduce the need for transmitting data all the way across the network. So that activity is completely understandable from the performance and business model point of view. It doesn't remove, however, the importance of the last mile connectivity to consumers. It just means that there's increasing amounts of connectivity directly to the large scale cloud providers with ISPs that are directly connected to customers.
Yeah, so I think the important thing to understand here is that the structure, the topology of the internet is fundamentally evolving, right? If you look at the internet 10, 15 years ago, you had sort of different tiers of internet service providers. You had the tier 1 ISPs. They were the transit providers. They made up the backbone of the internet. Then you had sort of the tier 2 providers, which were I would call the wholesale internet. It's the people that are the regional sort of interstitial networks that connect the transit providers to local internet service providers, and enterprises and networks and universities and hospitals and so forth that are larger sort of participants in the internet. And then you had sort of tier 3, which was the retail internet service providers. These early on were the dial-up phone banks where people would call in, and then ultimately became local internet service providers. But what we've seen is a whole bunch of consolidation. So the whole notion of I remember probably in the mid 1990s, say, shopping around in my local computer newspaper in Indianapolis, where I was at the time, looking at all the different internet service providers for dial-up service, and then they had the different prices, and you try to find the one that was best. All that's gone, right? We don't have the heterogeneity of different last mile internet service providers at this point, right? If you're a consumer and you're getting internet for your home, it's Verizon Fios or it's Comcast Cable, at least here in the Mid-Atlantic region. Yeah, Ben?
Oh, I was just going to observe that to give you some hard data, there were something like 8,000 to 9,000 dial-up internet service providers prior to the time that the dedicated services arose. And now you're quite right. If you were a consumer, and the question is, what choices do I have for connectivity to the internet from my residence or my business? The answer is 0, 1, or 2 often.
Yeah.
Maybe 3 if we include the 4G and 5G as an additional access method, but it's either fiber or DSL, and often only 1 or 2 competitors in any particular area.
Right. And again, I think you see the same consolidation. Well, the consolidation is a little bit different shape, but essentially what you see is this, the hyperscalers who are now trying to deliver low latency, high bandwidth content globally, have built out this massive infrastructure to deliver on that need to their customers, and have supplanted, right? It's not as though I need to access a transit internet service provider to get to Google, right? Whoever's providing my last mile internet is plugged in at some internet exchange point and has mainline access straight into Google. And so everything's kind of one hop away at this point. And we call this notion as sort of the flattening of the internet. Yeah. And it creates an environment where you have the last mile providers, you have the hyperscalers, and just the full mesh of interconnectivity between those is probably 80% of all internet traffic at this point. Which raises some really interesting questions from an internet governance perspective, because a lot of our internet governance separates the content providers, and they're all kind of managed through the Federal Trade Commission, and then you've got the telcos that are managed through the Federal Communications Commission. But the hyperscalers are kind of all of it in one, and kind of where we're headed with the internet. And I think it poses big questions for how we think about internet governance in the future.
Well, certainly it would be, if you were to look at the BGP routing, for example, you'd probably find exactly as you say that there's a smaller number of hops to a service, a cloud service now than there would have been in the past, because you don't need as much transit.
Yeah, so I guess I don't know whether this is a good thing or a bad thing. Certainly, it's a good thing for connectivity and low latency, high bandwidth communications. I would wonder: are we creating governance issues? Are there sort of lack of diversity issues? Right. So, what happens if there's some massive fault in one of the hyperscalers, sort of global networks? What effect does that have on sort of the internet resilience overall?
Not much, because the bulk of those interconnects are for cloud access primarily. With the addition of the LEO satellite systems, there'll be additional options for getting connectivity. So we'll have 4 or 5 different ways of getting from a consumer to any particular cloud service provider. You'll have either satellite hops, or you'll have access from cable or from telco services, and you'll have 4 and 5G. So there would be quite a variety of ways for the customer to get access to any particular cloud service provider. If one of the cloud service provider networks goes away, yes, it's likely that means that the customer can't get to that cloud, but they can get to the other clouds.
Here's an internet governance question. What do you see as the role of the ITU going forward with this kind of transition to hyperscalers, especially given that the UN Security Council, with China sitting on it, might be providing some kind of oversight or guidance for international telecoms?
I'm not sure that I mean, the ITU has 3 main pieces, as everybody knows. There's ITU-R for radio, there's ITU-D for development, and there's ITU-T for standards. And historically, the ITU standards have tended to be in the relatively lower layers of the internet architecture. The assignment of radio capacity is very much at the forefront in ITU-R and still extremely important. I don't see any change in that in the near term. So I'm not persuaded that the Chinese involvement in the ITU is necessarily alarming, if that's the intent of the question. It's still the case that the bulk of the internet's protocol work is done either in the IETF or in the World Wide Web Consortium for web-based applications. And for a lot of the wireless application, you see IEEE, especially on Wi-Fi and related access. And then you start to see the 4G and 5G stuff, which, if I'm remembering correctly, Charles, that's still 3GPP more than it is ITU.
Yes, although ITU sets the kind of high level requirements. So the 5G standards were based on the IMT 2020 set of requirements that were ratified by the ITU. But I think one of the concerns is that so here's the doomsday scenario, right? Is we're just now starting to talk about IMT 2030, which is going to be the set of requirements for 6G. And are there essentially ways that China could leverage its voting bloc of Belt and Road countries to sort of put things into the requirements for IMT 2030 that would have downstream effects on the cellular standards developed through 3GPP and the sort of internetworking protocols that support that through the IETF?
Well, so yeah, that's a very good question. And one counter to that, one tactic anyway, is to say, well, let's not be so totally dependent on 5G and 6G. Let's make sure that the Wi-Fi capability continues to evolve and other local wireless capabilities evolve. Don't forget there's satellite capability, which could be also to offset that. So I think it's important to make sure that there are alternatives to that particular access method, so that we don't end up having, the internet needs to work over all of them. We don't want to end up with an IP layer which is only going to work over 6G. That would be a serious mistake. Right.
And that's my concern, is that essentially well, so this is the genesis of new IP, right? Is so China in particular put forward a set of requirements for 6G, and a particular set of use cases that they wanted to be able to implement. They postulated that, okay, the actual radio technology isn't really important. It's the software-defined core, the virtualization in the core that is really taking us from the radio networks into really the telephony, the telecom infrastructure itself, right? And then in order to support those use cases, they came up with these ideas of mandate-driven architectures to move away from sort of software-based architectures, service-oriented architectures. And in order to implement the mandate-driven architectures, now we need to restructure the IP header in order to accommodate that. Oh, and if we're going to restructure the IP header, let's add some other stuff in there that the rest of the world probably won't like, and now you've got new IP. So I mean, it's a whole progression that started with at one point, but ended up somewhere very different.
So this is the first. You're right to bring this up. This is the hazard of while you're at it. The most serious four words in the English language. One of my big concerns about 5G and probably 6G as well as this whole slicing idea, which essentially runs backwards in time to the narrowcasting attempt to control and manage in some terribly precise way each little slice of access to the capacity of the system, whereas the whole idea behind packet switching was to take a really fast aggregated bandwidth and switch the packets like crazy. And before somebody tells you, oh, the holographic system requires X, Y, and Z, I have to remind people that while we were experimenting with voice and video in the early 1980s with very modest bandwidths, we were intending to include that capability. And you'll notice that as time has gone on and capacities have increased, that packet switching has been able to let us do what we are doing right this moment.
We're going to discover that 6G is actually ATM, and we're all going to be very confused.
Oh, dear. I hope not. Okay.
Let's take one question here about some of the impacts of data-centric networks. This person listed NDN as an example versus the present location-centric IP-based network of today.
Well, let me try to interpret that and make sure that I'm getting this right. One possibility might be the idea that you were doing routing based on content. This is, and I have never fully understood how to scale that. I mean, if the idea is that you announce with some identifier the information you're interested in, and this propagates through the network, and now anybody that has generated something which has the content of interest to you comes to you through the network. That's the way I interpret the content-defined networking. I don't understand how many, the size of the routing table could be infinite, because the number of things that you might be interested in isn't trivially compressed into a small number of identifiers. It's like the Dewey Decimal System in the library. So I haven't been a big fan of that particular tactic, even though I suspect there might be some smaller scale examples where it might work, like send me the next map square, because I've just entered into a region and you've identified that very clearly. But that's a pretty narrow example. Charles, do you have some sense of where to go with that?
Well, so I think it has a sort of a Flag Day challenge, right? There's no way to switch our whole internet and economy over to a fundamentally different sort of way of approaching it. And I also think that to a certain extent, we've addressed a lot of the NDN aspirations through things like content delivery networks that already are doing the caching and localization based on it's building it on top of IP as a separate sort of thing rather than building it fundamentally into the architecture. So I mean we've I think every study I've been involved in on sort of the future of the internet over the last couple of years has always tossed it out as something we need to look at, but then we look at it a little bit and then we decide that it's really not worth looking at. So
however, just to make the point, if you look technically at what the forwarding tables look like, there's nothing that would stop you from building a parallel forwarding table that was indexed by content, whatever the heck that means, There's nothing technically impossible about that, just like it's not impossible to run a different domain name system than the one we currently have in parallel. The problem, of course, is that as soon as you start doing that, your point is made that suddenly people who can't do everything end up not being able to communicate because they didn't do everything. You know, you did X and I did Y, and we go like this. You remember X25? One of the problems with X25 is it had so many alternatives that sometimes when you got done negotiating, you discovered that you had nothing in common.
And with that is just about all the time we have for the discussion. I'll leave it to, offer some final comments for our speakers and then turn it over to you.
So Vint, I have a question. I heard this sort of folk tale about you trying to get residential internet service, and you wanted 2 IP addresses rather than 1. And the poor technician you were talking to at Comcast or Verizon or wherever was unwilling to grant you a second IP address, not knowing that your founding role in the existence of IP addresses.
Yeah.
And I want to know, is this story true or not?
Not quite, but it's close. This is the Verizon file service, and what I actually wanted was not a dynamic IP address, but a fixed IP address. And they said the only way you could do that was to order business service. So I ended up ordering business service. The funnier situation was when my service stopped working, and eventually it turned out that somebody had failed to renew my service, and then they decided to renew it internally. But that meant that they hadn't got my voice recording saying that I had asked for service, and so they had a bit set saying that no TCP connections would be permitted, even though I was pinging to get things. I was saying, how come I can ping, but I can't open a TCP connection? And eventually it was said that the commercial people had not gotten my voice recording to authorize service. And this caused the engineers a certain amount of pain, and of course I was hollering at them all the time. Anyway, it all worked out fine, and I'm now a happy customer running at somewhere on the order of 300 to 400 megabits a second up and down.
With a static IP address, no less. All right. Well, thank you very much for your remarks, Vint, and thank you, Rachel, for your expert moderation here and keeping us on time and on topic. So with that, I think we're going to switch over to the second half of our program. So it is my pleasure to introduce Nadia Schadlow, who is our panel moderator. Nadia is a visiting fellow here at the Mitre Corporation, and most recently served on the National Security Council as the Deputy National Security Advisor, where she served as the principal author for the last National Security Strategy. So she has been dealing with the rise of China in technology for quite some time now, and is really an expert in that area, and is gracious enough to serve as our moderator. And I will hand it over to her.
Thanks so much, Charles. And it was really interesting to listen to you and Vint and Rachel. And I'm looking forward to hearing what our panelists have to say about the topics that were just raised. So what I'll do now is I'll briefly introduce the 4 experts that we have with us today. And then I'll turn to them and essentially follow the same format that was just followed, and so that they have a chance to comment on the themes that were just discussed, the themes of connectivity, of geopolitics and the bifurcation of the internet, and finally, some of the hyperscaler issues. So we're lucky enough today to have Diane Rinaldo with us. She is at Beacon Global Strategies and is one of the country's leading authorities on 5G, telecommunications, and the internet. We also have Milo Medin, who's currently the Vice President of Access Services at Google. And most recently, he spent a lot of time writing about which parts of the electromagnetic spectrum should be used for 5G. So he's monitored and navigated a lot of these debates. We have Michelle Connolly, who's a professor of practice in the economics department at Duke. And previously, she served as a chief economist at the FCC. And last but not least, we have Sam Visner, who's a cybersecurity and national security expert, and he's currently serving at Mitre as a tech fellow. And previously, he had the position of director of the National Cybersecurity FFRDC there. So we have a really highly qualified panel, and I'm interested in hearing from them. So first, we'll start a little bit, I think, with the issue of connectivity. I think Rachel did a really good job in capturing some of the fundamental issues. She pointed out the importance of the issue. There were queries and questions about the haves and have-nots. Vint commented on the rapid evolution of connectivity with undersea cables and more. We heard Charles talk about the technical challenges also of connectivity and the implications of 5G and 6G. So I'm sure all of you as experts were probably taking notes and are eager to comment. So why don't we go ahead and start? Does anyone want to start first? Maybe just for ease of running this, if you sort of if one of my panelists raise their finger, that might be the easiest way, and I can call on you. So Diane, thanks.
Thanks, Nadia. No, I'm happy to take this question first and talk about a little bit about connectivity. The entire world, including the United States, has been struggling with connectivity. But I think with the advent of 5G and as we look to 6G, it's going to alleviate some of these issues. We have a new business case that is being developed, and that 5G is going to help bolster smart agriculture, something that you often hear about in one of the use cases for 5G. If we're able to create a use case in rural America to build out 5G, there's going to be extra bandwidth, and that will allow for in-home broadband. So we can move towards a wireless broadband connection and to provide services to areas that haven't had great connectivity over the years. I know in the UK, Cisco is currently building out in more rural areas using Open RAN solutions, which is the concept of standardizing the interfaces between subcomponents and allowing more competition within the subcomponent level. And that's allowing them a business case. It's costing less to build out in these areas because of the technological innovations that are occurring, and as well as the different use cases in these more rural areas. So, it's a great time to be in this space and to talk about these issues and to see how technology is further advancing the lives of so many people in this world.
Thanks, Diane. Do any other panelists would like to comment on this?
Yeah, this is Sam. I'd have to agree with Diane. As I've watched over the last couple of years, I think we've seen how this connectivity is revolutionary. It's not just a few more lines. It is, as Lenin once said, quantity has a quality all its own. And in this case, I think this will change economies. It will change learning. It will create more transnational communities of interest for better and perhaps in some cases for worse. In addition to working in Mitre, I'm an adjunct at Georgetown. I was able to teach, and I think we had a pretty good course, 40 undergraduates in the last semester, and we did it all virtually. That would not have been possible. And interestingly enough, the course was about cybersecurity and global connectivity. So if one thinks about the level of collaboration, which I think perhaps was useful even in the development of these new vaccines from which a number of us are benefiting, I think that this is terrifically exciting. But the excitement also is anchored to some of the incredibly interesting challenges. How do we impose governance and how do we have good behavior in essentially a global connectivity environment in which people can self-identify and self-affiliate? And we're seeing some of the negative consequences of that, both overseas and more recently in the United States. So as a friend of mine likes to say, this is a wicked problem. It means it's a lot of fun, but it doesn't mean it's easy and it doesn't mean it's all good.
Yeah.
Thanks, Sam. Milo?
Yeah, I would agree that connectivity has moved out of the realm of something that is nice to have to something that is now essential. If you think about the services that we use and how we communicate with each other, how we engage with each other, it adds a huge amount of tax if not everybody is connected. And so the price for being disconnected is an all-time high, and that's motivating a whole set of investments from mobile networks to satellite, new systems architectures, et cetera. I would say, though, I'm an engineer, so I have certain limitations, right? One of the challenges, if we look at the network, there's only one real network, and that's the wired network. The wireless network is just an extension, a little bit of distance off fiber optic networks. And so if you are not a leader in fiber deployment, you're not going to be a leader in wireless deployment. And that's a challenge, especially for the United States, because going to 5G and getting real benefit from it requires the deployment of much higher frequency networks than we are used to. One of the benefits of 5G is that we can aggregate up to 500 megahertz of spectrum at a time instead of 100 for LTE. But that only helps you if you've got that much spectrum. And to get that much spectrum, you can't do it just at the same frequencies that we did for our normal LTE networks. If you put 5G on the same spectrum that 4G is on, you can get maybe a 20% performance improvement. That's what we see today with the T-Mobiles and the Verizons deploying in sort of traditional cellular spectrum. But if you really want a 10x improvement, something that gives you game-changing speed difference, enables new applications, that's going to require you to deploy up in the 3 or 4 gigahertz range, or even the millimeter wave range. And that will require probably at least 3 times the number of base stations that we have deployed in the United States today, even just to get to 70% of Americans covered. And so that's a challenge with our infrastructure, especially when you compare it with our competitors, where in Japan, you have utility fiber that you can get pretty much dark fiber anywhere for about $50 a month. And in China, where I think they have north of 400 million fiber to the home customers all connected. So that base of fiber enables you to extend wireless in all sorts of new ways.
Thanks, Milo. We have a couple of questions now from the audience, so I'll turn to them. The first one is, isn't there a dichotomy of telecom consolidation, hyperscalers, versus the goals of diverse supply chains? So how to reconcile essentially these two tensions, the consolidation, hyperscalers, and the goals of a diverse supply chain? Does anyone want to take that question?
Sure, I can try and address a little bit of that. It's interesting. You're right. There's a divergence. The cellular industry is dominated by Chinese and European suppliers. There are no American suppliers of cellular technology to speak of. On the other hand, on the hyperscaler side, they're all dominated by American suppliers, vertically integrated. And American companies' leadership in cloud gives American companies and American values a great opportunity to expand and to influence how internet is used across the world. So you're right that the supply chains are very different, but it's not clear to me which one is the problem.
Right, because they're interconnected, yeah.
Let me respond to that if I could. I think Milo is right, but I think the situation might be changing. I think a new kind of hyperscaler may emerge, and we're beginning to see how that can happen. What China's doing with One Belt, One Road and placing along that One Belt, One Road a digital Silk Road is building a new IT infrastructure with smart cities like Alibaba's City Brain, with an IT infrastructure of Chinese products, Chinese technology, and Chinese governance of the cyberspace that they're creating. So these smart cities spread out along this digital Silk Road, dominated by Chinese companies, some of which are Chinese national champion firms that are working in concert with the Chinese government, I think could emerge as a new kind of hyperscaler and try at the same time to create a new kind of governable cyberspace through their hyperscale operations. And I think we're beginning to see we're beginning to see this with the export of things like City Brain to countries like Malaysia and potentially to countries in other parts of Asia and into Southern Europe.
So in a way, we might be able to circle back on that a little bit during our bifurcation and geopolitics discussion. I would like to ask one more question from the audience. The question is, if 4G enabled the social mobile internet, 5G enabled the Internet of Things, what's the use case and business rationale for 6G? And that goes to actually Diane's, I think, earlier point about use cases in agriculture and sort of spurring connectivity for some of those use cases.
Yeah. Sorry.
Sorry, go on, Diane. Yeah.
So I was working on Capitol Hill at the advent of 4G. And back then, we did not know what it would produce, right? And so we got the app economy from it. And I think as we look ahead to, the 2030 time range is kind of what we're thinking for 6G. We can talk about autonomous vehicles and mass drone use, things of those natures. But the real benefit is, the creators are thinking right now of what they can do with higher speeds, lower latency next to zero. So I'm not an engineer, I'm a policy person, but I think it's fascinating to watch it from the entire mobile ecosystem, from nuts to bolts to the innovative side. Right now, with talking 5G, we focus so much on let's just get it up and going, but it's the back end, the economic side of things that's really going to change the outside of our economy and the world's economy on the next big tech innovation that will lift us all up.
Thanks, Diane. Would anyone like to comment on ideas about future use cases on 6G? Milo, I'm sure you have an idea or two.
I mean, I would say a couple things. I think a lot of the use cases that are being talked about, autonomous vehicles, et cetera, are actually not ever going to happen, and at least driven by 5G or 6G. Part of the reason is if you think about all the small cells that have to be deployed to provide this kind of speed, how many of those cells that are sitting on light posts or on sides of buildings have emergency power? So when the power goes out, all your capacity networks go away. And you can't have autonomous vehicles just stopping because there's a power failure. So there's a whole class of problems that we have to solve if we want to enable those kind of applications. On the other hand, if you think about the combination of low latency and high speed, think about personal robotics. The vacuum cleaner robot right now has a fair amount of smarts built into it. But if all you needed to do was just have cameras and sensors and having that data go to a cloud, and then having the cloud control the servos and have the thing move around, whether it's robotics in the home or industrial automation, that enables not just a dramatic reduction in cost, but enables fleet-wide learning so that you've got new AI models and the rest that can constantly evolve and the entire fleet gets smarter at once. So I think that you're right. There's a whole set of things that are going to happen with augmented reality and robotics and the rest of these things. I don't personally think a lot of the use cases that people have talked about now are actually likely going to be the things that happen.
If I could just add on to what Milo said, as somebody who lives in Annapolis, Maryland, I'm really hoping that autonomous vehicles works.
They will work, but they won't depend on any 5G network.
Milo, come on.
There are a lot of car companies that are going to be upset with you, Milo. So, okay, a final question in this domain, and then we'll switch to our next subject on geopolitics. With all this new connectivity, how do we address the topic of equity and reduce the digital divide? Are there policy or regulatory things that we should be thinking about? How can regulations maybe impact this domain of connectivity?
This isn't an area where there isn't precedent. I mean, if one goes back, Vint Cerf was talking about Vail and the Vail Accords. When AT&T was granted their monopoly, and I'm certainly not arguing for anything like that, there were certain conditions associated with this. Among those was the right of universal access, that some basic telephony would be made available to everybody, regardless of their means. I don't know that it ever got to 100% penetration, but I think it caused telephonic penetration in the United States probably to be about the best in the world, given both the technological innovation and the fact that the government insisted on universal access. one question that we have to ask, and we tend to shy away from this question because of ideological problems, is whether or not at some point this is a public good. And a public good means that there is a public interest in providing it, and it doesn't necessarily have to turn a profit in every case. I would say that we're facing an interesting world. We have 328 million people in the United States. China has 900 million people online. So they have they may have some competitive advantage. I'm not saying that that's a bad thing, but I am saying that, we may need to address this by, in essence, printing some money, or I don't want to use the term printing money, but regarding this as, in fact, a public good, and saying that there must be some aspect of universal access. The large companies, those that are hyperscalers, I think, may have a responsibility, along with their tremendous economic firepower, to help us achieve this.
Right. I'm going to give Michelle a chance to weigh in. She spends a lot of time navigating regulatory issues.
Yeah, so I think, there are a couple things to mention, partially in response to Sam. One is that, there was the Universal Service Fund for telephony. And so it wasn't simply conditions imposed on AT&T that helped increase that. And there's also been a lot of debate as to whether even the Universal Service Fund was quite efficient at achieving that in terms of the price that was paid, and the fact that now we're still covering a lot of the Universal Service Fund is becoming larger and larger, and we're running into difficulties because of the way that it is taxed, and that base becoming even smaller. Now, that was switched to broadband deployment with the use of the Universal Service Funds to allow for reverse auctions for groups to promise to build out in unserved or sometimes underserved areas, primarily unserved areas, to avoid overbuild. So it's not the case that this issue hasn't been seriously considered. There are actually a lot of government funds currently. In fact, it might be a little strange because there's the agricultural rural areas that are doing some subsidies for this, and as well as the FCC. But one issue that doesn't seem to come up enough, I would argue, is that initially we thought we were always arguing the broadband, the digital divide was really being driven by a lack of access. And what is happening is access is not the only dimension that is driving the digital divide. So to Sam's point, it may be an issue of, well, maybe a household doesn't have enough money to get this. And then, there can be an issue of whether the government wants to consider that. But there are also issues that there may just be households that, at least currently, even in COVID times, may not find accessing the internet to be a useful proposition for them. If they don't know how to use a computer, if they're not working in a job that uses these kinds of things, if you're 80 years old and you've never done this, you're not going to see a value. I think that portion of the population is going to become smaller and smaller over time, clearly, especially as older generations are aging out. But it's not something that I would argue we'd want to consider a utility, in the sense of having government step in and try and be, a sole provider, or try to create some monopolies. I think that would be a bad system.
I'm sure we could spend, we probably should switch to the next topic, although I'm sure we could actually spend a lot of time just on that subject of the internet as a public utility, an idea for a future panel. So I will switch so we have enough time to consider, unless someone, it is a pretty important topic. So does anyone have a last word on this topic? Milo?
I would just say, if what you really want is a broadband deployment, policy should be optimized for that. Mm-hmm. So like this last auction on C-band, I think is a disaster. You're sending $85+ billion into the US Treasury that could have been used for network deployment. And, if you had made build out, or at least putting construction funds into escrow as a bidding qualification for that spectrum, it would have greatly depressed the value to the Treasury, but you would have at least incented the deployment of infrastructure, deployment of fiber, deployment of American companies' technology, and other set of things. So I think we need to think about how to align policy around deployment, and that will mean changes in the way we do things and the coherency of government action.
Could I respond to that? I mean,
Sure.
the auctions have deployment requirements, so I'm not entirely sure.
Not to build in reasonable times or large sections. Substantial service is a checkbox.
Well, I mean, different auctions have different levels, but there generally are deployment components. And I would argue that the auction system is very crucial in terms of making sure that the entities who are most likely to be able to deploy are getting access to it. So I think it's a fundamentally important mechanism by which we guarantee, or we attempt to guarantee that this very finite resource is being offered for use to the best participants, the ones most able to deploy.
Michelle,
We don't have any money to deploy after this last auction, unfortunately. That's the problem. So we can fix that in how auctions are structured, but we got a problem here.
I'd like to come back to a point that Michelle raised earlier, and it's a point with which I agree. Even if we make connectivity available, and I hope we do, there are people who don't have the technical literacy, or they just don't within their, as we say, pattern of life, find information technology of this type useful to them. Who was it who said, never let a crisis go to waste? I think it may have been Rahm Emanuel, but whoever said it, we have a crisis now called, the COVID pandemic. And I think one thing we can be doing is using the process of getting Chromebooks and other low-cost computers out to students and getting them connectivity, not only to give them the technology, but show them how to use it, and through them show their families. I don't know what mechanism will work for providing this kind of economic literacy to this kind of technological literacy to seniors who are not familiar with it. That's a problem I'm clearly not smart enough or young enough to solve. But I think we ought to try to solve it. And I think, the current pandemic gives us, if anything, more incentive to doing so than we've ever had. So hopefully some of the people on this in this session will go home and, as we say, and lose some sleep over this problem.
That's a good way to end the session, and you can already see formulations of public-private approaches to addressing some of those points. So I'll switch over now to geopolitics and internet governance. I'll recap because I think with COVID, everyone's short-term memory seems to be affected, at least mine. So I'm going to recap a little bit the comments that Vint and Charles made previously, some of the themes. One was how competition will play out on the internet. How will it be manifested? Will it become bifurcated because of the ongoing geopolitical competition with China? Will e-commerce serve as a glue? Or will the pullback from globalization, have a greater effect? On the other hand, Vint made the point about undersea cables, and lower costs of building those actually could create a motivation for easier separation. Vint, I think, argued there was no real appetite for two distinct networks. He made the point, I thought, an interesting point, which would take us back to 1910 when telephone networks were different and not efficient. Charles, I thought, was very interesting. He highlighted the various types of bifurcations. Different levels of the stack could bifurcate in different ways, and that would have implications as well. So these were some of the themes the previous panel talked about. I thought we could now jump in and comment on them, and then, of course, take questions. Thanks. Sam, I see your mute went off first, so we'll go with you, and then Milo is off too, so we'll go with Milo next.
Well, things are happening very quickly. And I'm reminded again of another controversial leader, but when Zhou Enlai, the Chinese leader, was asked reputedly in 1960 for his opinion about the French Revolution of the latter part of the 18th century, he said, it's too early to tell. And sometimes I feel like as we look at all these trends, it's too early to tell what's really going to happen, based on what's happened in the last 24, 36, or 48 months. But I'll take a couple of guesses. One, I think Vint is correct. I think China's efforts with new IP and to essentially promulgate an idea about a severable internet is not going to work very well for them. I don't think the standards bodies are going to go for it. There's no compelling need for it unless you have an internal political need to do this. And I think apart from China, most of the countries that might want to do so don't have that much influence in the standards bodies. So my prediction is that won't work. However, what may work is that as China continues to invest in other countries along this One Belt, One Road initiative, which is gigantic, and they are receiving some pushback because countries don't like being told that for the next 100 years they're going to pay back the investment in their natural resources. But if they're successful and they build out their own infrastructure there, then they will create a new kind of cyberspace, not an electromagnetic domain in which we exchange information, in which cybersecurity is about the protection of that information, but a domain of human governance, of sovereign territory, where cybersecurity is about governing human beings.
Right.
That's what they're attempting to do. So whether or not we have two different standards or architectures, we may end up with two different kinds of resulting cyberspace and cyberspace governance models. One, a model that represents, liberal democratic values, and one, a model in which cyberspace is essentially governable sovereign territory. I don't know if that's going to happen, but I think that's what they're trying to do. And I think, we need to find useful alternatives to make sure that that model doesn't dominate.
Thanks, Sam. Well said. Milo?
Yeah, I think it's important to talk about what standards actually are useful for, right? They're useful in terms of building stuff that works together. And there's no question that standards are driven primarily by people who build and sell equipment. And to the extent that Huawei has gone in the last, 10 years from 10 billion of revenue to north of 100 billion in revenue and has very large market share, they and other Chinese vendors have outsized influences in a bunch of standards groups. Not so much the internet groups, but certainly 3GPP, the ITU, et cetera. And then I firmly believe that semiconductors drive standards far more than regulatory bodies do. And if you just look at what the drivers of chipsets, et cetera, goes back to equipment providers, handset providers, and the rest. And if you've got an ecosystem that is dominated by Chinese vendors, then they can integrate additions to standards and other technologies quite easily. And there's not much that can be sort of done about that. So this goes back to who is deploying infrastructure, because it drives the commercial ecosystems. If you've got a vendor who's got government-owned telcos spending huge amounts of money on equipment deployment, that enables them to invest in R&D and enables them to export that technology at lower cost to other countries and to gain large market share. And I think that's a real challenge. It's really about stuff that drives standards and drives the kind of capabilities that people either enjoy or have to deal with.
Well, that's actually a good segue to one of the audience questions, because the digital Silk Road is in many sense that infrastructure that will drive some of that stuff. And so the question was, what should the US, the EU, and other allies do about the digital Silk Road? Are we too late? Are you worried? Are the panelists worried about this? Does someone want to expand upon that a little bit?
Yeah, I'm happy.
Diane? Yeah, thanks.
So while there are many things I like about Charles Clancy, I do love that he is out front on this issue of 6G. As someone who spends the majority of my time talking about 5G, I can tell you that it is taking everything we have as a country to get out there to deploy 5G. 6G, we need to be talking about this now. Milo and Sam are right. We need to take more of a stance in participating in standards bodies. We need to encourage companies to send representatives. We're just not seeing the attendance that we should be, that other countries send. And while you can flood a standards body, it's not going to change an outcome at the end of the day, but it does matter. It does matter that you have people there and are convening and are brainstorming ideas. So it is incredibly important that we focus on these things. So just looking forward to 6G, we need to think long and hard about lessons learned from 5G in the struggles that we've seen. And again, as Sam mentioned, and I know he's a spectrum expert, but the ongoing battles between the FCC and the NTIA, an agency that I used to run, and very public. We need to figure out kind of the breakdowns in communication and look forward. As I mentioned, I was on Capitol Hill for 4G, and back then it was the broadcasters, it was at NTIA for 5G, and it was the Department of Defense and government users. We need to figure out a way forward and work together as a nation so we are ready for 6G. As I've said before, 5G, we're going to get there. We're going to give our smart engineers who are thinking about that next best technology the tools they need. But for 6G, we need to start thinking about this now, or we're going to be left in the dust.
So from a regulatory or policy perspective, are people starting to think about that in the U.S.? I mean, China's only part of the equation. Some of it is, as you said, Diane, we must speed up. Are there things that we can be doing in a regulatory framework, Michelle, that we could do better to get ahead of this?
Well, I mean, one issue that comes in my mind is an issue of federal preemption of state regulations. The fact that we have a lot of state regulations they vary and they are easily captured by certain groups, and that does seem to hamper the deployment in a national sense. So I think there are some issues, and we even saw that under Ajit Pai and his ruling on attachments in local municipalities. So we've seen that has been an issue in the past, and so I think he was very much right to do that. But we continue to have issues of that nature that certainly from a regulatory standpoint could be preempted, not to use a pun, but, preemptively used and could help with deployment issues.
Thank you. Does anyone want to, Sam, do you have anything to say on 6G, or also even back to the digital Silk Road, where it occurred to me, where Milo or Diane, what is the internet for? If it's from China's perspective, a mechanism of control, of governance, to your point, Sam, then how do we avoid bifurcation down the line if that's the implication?
Healthy, and thank you, Nadia. And I think the way I'd answer that is healthy, robust, and forthright competition. Look, we tend to look at China and we pretend that we forget that they put their pants on one leg at a time, just like everybody else. At least I think so. I look at it this way. They are suffering from a couple of enormous disadvantages competitively. One, the Silk Road's a kind of bad deal. For one thing, the model that they are trying to impose may be attractive to some of the governments, but it's not a particularly attractive model. Most people do not want to be subject to persistent surveillance and persistent governance in cyberspace or using cyberspace on the street to find out whether or not they crossed against the light. That's not an attractive proposition. The second thing is that the countries that are buying into this are mortgaging their futures, and some have started to push back, understanding that their economic future is in fact anchored to their ability to repay the loans necessary to get this financing. Now, we have some tremendous advantages. We have, I think, more attractive values. We're better technological innovators. Although the Chinese have become quite good, they're going to put a lander on Mars. At least they're going to try, and I think there's every reason to believe they're going to succeed. But we also now, and I don't want to make a political comment, but if we work with our partners, if we work with our allies, if we work with our European allies, with our allies in the Far East, with our Five Eyes partners, if we decide to do this in concert, our economic and technological firepower is superior. And we can offer investment alternatives to these countries such that they can still enjoy the benefits of advanced information technology, 5G, 6G deployment, IoT, IP version 6, AI, ML, and smart cities without necessarily mortgaging their economic future and without necessarily having to buy into the governance values that this authoritarian model would offer. So work with our partners, build up our, rebuild the coalition of countries that are like-minded, that also are technologically innovative and advanced, and get out there and offer an alternative and be quite forthright about it. That's how I do this.
Thanks,
as a
Sam.
policy imperative.
Diane, and then Milo, did you have a comment on 6G? Because I thought you did. And Diane, on this point.
No, I just want to follow up on international cooperation.
Yeah.
I have a side job. I am the executive director of the Open RAN Policy Coalition, where we spend a lot of time talking to our policymakers around the world, international policymakers. We've talked to 27 countries in the past 5 months, and we are hearing the same thing over and over again. No one feels that there's a good space to have these types of conversation. The G7's not encompassing enough, G20 too big, ITUs regulatory. So there is a desire out there among our allies to come together to discuss these issues and to figure out how to move forward. And as Sam mentioned, there are things that we can be doing. It's not the United States going alone. A lot of developed nations, a lot of our allies have funds such as USAID. Let's pool our money together and help the more developing nations build out their telecom footprints to combat some of these issues with China going in and building out with Huawei, and then just having a permanent foothold. And as we know, through our own process of rip and replace, once you have a telecom footprint, it's incredibly hard to move off it.
And there have been, to that point, there have been some proposals recently for creating a T10, right? A tech sort of the 10 countries we want to work with. And so I think that's an effort to create some new approaches to this problem set.
We hear,
go on.
So we hear about the D10 a lot.
Right.
The Brits brought it up. It never really went anywhere, but from countries all around the world, they keep mentioning the D10. So right. I hope.
But I think there's one called, I might be wrong, a T10 with the effort on the tech, but I could be wrong. No, I'm not sure. Maybe.
Everyone has to put their own spin on it.
Exactly. Milo?
Yeah, I think I was one of the co-authors of the Defense Innovation Board report on 5G. That came out. The unclassed version is out there. The classified version, for those of you who have clearances, is much more interesting. You should read it. One of the points we make in the report is, in the 90s, Europe dominated wireless services. It was the early and pervasive deployment of U.S. carriers of LTE that enabled companies, U.S. tech companies, and whole sets of innovators to build new applications and services. And as LTE went to the rest of the world, all of those services went along with them. And so that's the reason why, in 2010, 10 out of the top 10 internet companies by revenue were American. Today, 6 out of the top 10 internet companies by revenue are American, 4 are Chinese. And I think the real underlying challenge is not things like Silk Road, though they are challenges. It's if China deploys advanced networks first and becomes the place where innovation and new services happen, they will execute the same play that the US did. And then in the next decade, where will the dominant apps be? You see TikTok being very popular. If you look at the Indian App Store, you have very large numbers of App Store on Android. You see very large numbers of Chinese apps that are the most popular. And so if the infrastructure leads to these kind of differentiated applications and services, and then as the rest of the world follows, all of those apps and services will come from China. And that means the data that consumers store in those services will be stored in Chinese data centers. It makes the Chinese cloud providers more competitive globally, and that's a problem. And so I'll speak for our company, we typically don't build products that don't work well in our own home market. So without US infrastructure being global leading, you're not going to get global leading applications and services that ride on top of that will then go to the rest of the world. So some of this is trying to counter China, and I think we have to do that with allies, but you've got to generate enough of a market of services and technologies and deployments here before you can help shape what the rest of the world does. That's what it means to be a leader. People follow you.
That's very interesting and actually directly relevant to a solution, a way of thinking about a counter to the digital Silk Road, to develop our own operational concept based on what you're talking about, Milo. So we have another audience question, which goes back to some of the 6G issues. I'll summarize it, but essentially, I think it's to your point that you made earlier about what do we do about reinvesting the proceeds of the C-band auction in things that would enable the telecom ecosystem to balance the impacts. Should we be investing in 6G R&D, for example, or grants for states to build out infrastructure? So I think we addressed that a little bit, but does anyone want to talk to that a little bit more explicitly? Diane?
It's just great. So I would just say that I think we need to be careful about empowering any district, state to build out their own footprint. The private sector is doing a pretty good job, and it's incredibly expensive, and upkeep is incredibly expensive. I think we need to look ways to cut red tape and make it more efficient for business to get out there and to build. And as we talked about different use cases that 5G is going to bring along, I know Milo was talking about fiber. There's been a bill from Congresswoman Anna Eshoo. Gosh, she's probably introduced it the past 5 Congresses about what's it called, Milo? Build once, rip once,
yeah,
dig once.
Dig once.
Yeah. So if there's a construction project going, at that time you would lay fiber, and so you wouldn't have to disrupt the ground, which is, as you know, is part of the big problem with a fiber. So it's just smart policy decisions that can go a long way in ensuring people have connectivity.
Yeah, I work with NSU staff on a couple of those, and it's really interesting the pushback you got from the U.S. government. The Highway Administration and Department of Transportation said, literally some of the feedback was, why do you want to put conduit? We didn't even say fiber, just put the hole in, right? The conduit so that you could pull fiber later. And they said, why would you want to put conduit in on these rural areas? Or hardly anybody lives out there. Why do you need why is there a need to put fiber there? And so the problem with the US government is one of coherence. How do you get everybody on the same page and optimize a particular output? That's why I personally think OMB is the nuclear weapon that can drive that coherence. If it is the meat axe, not the scalpel, but there are ways to make the agencies all look at broadband deployment as one of their core objectives that they are measured on. I do think I think the C-band auction and the financial markets right now have just huge, indicate there's a lot of capital available. So I don't think the issue is capital, but the issue where is spectrum? Where is easy to build right away? The electric power grid is a great piece of infrastructure that is not used very much to advance communications goals and objectives. Why? There's 700 utilities. They're all sort of dominated by state PUCs who do not want the utilities doing telecom, by and large. And so again, there's opportunities there to lever infrastructure, because the way you make infrastructure economics work is sweating the asset. How you've already got a bunch of infrastructure that's available. What can we do to incrementally enable that to allow the US to have the best communications infrastructure in the world, which we're not on a path to right now.
And actually, I want to completely agree with Milo here and reinforce what he's saying. I personally testified in the Georgia Public Utility Commission last month because they regulate it themselves, and it was one of the worst cases of regulatory capture I've ever seen. I'm a bit biased, but I provided actual data and empirical analysis, and it was entirely ignored. The decision was made entirely to support kind of local municipalities and local co-ops who are providing electrical service. And it's astonishing. And this is the reason why I mentioned the preemption, federal preemption of state laws. And also that's also possible because Congress had exempt municipalities and cooperative pole owners from the pole rate attachment regulations when they imposed it. So I think that is a major problem.
Thank you. I had not heard the term regulatory capture before. There are probably other things one could call that, but so we'll, okay, so we'll move on to the last topic, hyperscalers and what they mean for the internet. So I think, Charles and Vint, we spent some time talking about this. They pose big questions for how we think about internet governance in the future. They're good for connectivity in many ways, but are we creating governance problems, issues, monopolies, lack of diversity? And if there's a massive fault in one hyperscaler, what could the effect be? There was a difference. I think Charles was more concerned about that. Vint was a little bit less concerned. But maybe we could just turn to the broad topic of hyperscalers, and then we'll close out. So who wants to go first?
Well, they're going to be some, yeah. I wouldn't call myself an expert, but I think inevitably there will be some. There are efficiencies to be gained in building infrastructure if a company is large, and these hyperscalers have managed to recognize and to capture those efficiencies. And even if we don't like it, and there are times when perhaps we don't, I think that China will also try to deploy its own hyperscalers. We're trying, we're not deploying them, but we allow them because it makes economic sense in some cases. They're doing it because I think to some extent it serves as an instrumentality of their geopolitical policy. Interestingly, Alibaba and Ant in China have now started to suffer some regulatory backlash. I don't know if it's because they're too big or the Chinese government feels that they're not operating sufficiently well as national champions. One thing I'm not sure about is whether or not hyperscalers remain absolutely inevitable. It seems to me that every time we think that no possible competition can emerge, that somebody does emerge. It wasn't clear to me 5 years ago that we would have a global 5G satellite-based network. But now with over 1,000 satellites up, an interim point of 12,000 in prospect and as many as 40,000, Elon Musk is going to be a competitor, and he's going to link his system with Microsoft Azure. That's a different kind of separately owned components of a new kind of hyperscaler. So I don't think the model that we see today is necessarily going to endure forever, and I don't think it's inevitable. But I'm not sure what will replace it.
Thanks, Sam.
Yeah, I'll just add on that. I don't think it's pejorative. As Sam mentioned, that you're gaining a lot of efficiencies by being a hyperscaler. Building out telecommunications networks globally requires a lot of players on the field. And there's definitely a place for hyperscalers. There's definitely a place for new competitors to come into the market. So I think that, again, it shouldn't be a pejorative term, and we should kind of ensure that we are bringing in the best minds, the best technologies to bear in order to remain dominant in this space.
So there's less concern I'm hearing from Sam and Diane. What about Milo?
Well, I work for Google, so obviously I have a
right.
perspective. I would say a couple things. It is the internet architecture is evolving, and it's not just the cloud providers. If you think about 90+% of consumer traffic is coming from CDNs. Now, YouTube is a big one, but Netflix, I think, is even bigger than ours. And so that's a very interesting kind of animal, right? Because you have so much video traffic that deforms the interconnection and the distribution of traffic. But I will say that had COVID happened outside the era of the hyperscalers, the economy would have been far more devastated than it has been. The ability to move to work from home is only possible because the data that you needed to do work was in the cloud and accessible. We didn't have to go do massive upgrades to in-company data centers across the country in order to enable remote work. And if it's all right with you guys, I would commend 2 reports from the North American Network Operators Group on internet traffic patterns. I'll put them in the chat. These are by Craig Leibowitz, and you get a good sense of how traffic in the internet has sort of both changed as well as enabled new sorts of models. So, I think the reason you've got this is because it's the most economic way for traffic to flow. And the fact that this has overwhelmingly benefited US companies, net is a really positive thing from a national security perspective. You want consumer data stored in US company infrastructure as opposed to Chinese.
Thanks. We have one question from the audience on the relationship of antitrust laws to hyperscalers. I think, all 3 of you implied an answer to that, but does anyone want to take that on directly?
I'm not a lawyer, but it doesn't seem, I have not heard that it's been an issue. It's more, correct me if I'm wrong, is anyone a lawyer? Antitrust is usually more horizontal, where this would be vertical. Does that sound right?
I'm sorry, I missed. Can you repeat what you?
Sure. Whether or not antitrust laws have any have a relationship to this hyperscaler question, if how they would impact this overall issue.
Well, I mean, there are issues with vertical integration that can be brought to DOJ. The standards are quite different from horizontal mergers, but I think that is something that. I've spent a lot of time debating people that in policy circles, there are groups who are inherently always worried about big companies with a lot of power. And in some ways, maybe adding the word hyper might not be helpful in that kind of a policy setting. So, but the groups who are arguing for additional oversight are arguing that the current antitrust laws aren't sufficient to deal with these issues. I'm just presenting the debate here, not my position. And so it certainly can become an issue, and it's being brought up a lot.
Okay, thank you. Well, as we close, I want to give all the panelists, first of all, thank you so much. I learned so much from all of you, but just a time for a final comment. Sometimes in these sorts of situations, you think of something that you wanted to say but didn't, so don't feel obligated. But maybe I'll just sort of go back. And Diane, any closing remarks on any of these 3 topics that we talked about this evening?
Yes, first, thank you, Nadia. This has been a great session. And it's been wonderful to be with you all today. As I said, it's a great time to be working in this space. And a couple of things of note. I think education plays such an important part in this conversation. We need more engineers. We need more RF engineers, starting kids young, STEM programming, and just try to introduce kids into this line of work. As the former head of NTIA, HR was our biggest struggle in getting people in the door. So also while educating people on, the core math, science, engineering, but also giving them a sense of government service, which is an incredibly important part as well. So again, I appreciate you talking about these important issues, talking about 6G, which we need to focus more on. I do so much on 5G. I think I'm just going to start changing my talking points over to talk about 6G.
Great. Thank you so much. Sam, did you want to have a final comment?
Sure. First, I don't know what every use case will be for 6G or even 5G, but I guarantee one thing, those use cases will emerge. We may find ways to essentially do far more interesting things even on the battlefield, or do far more interesting things in the governance of our cities as these technologies roll out. So while I don't know what the use cases are, I remember when people said, what do I need a computer for? And then, 18 months later, if you say, well, if my computer doesn't work, I have to go home, I'm having a nervous breakdown. And I think that will happen. As we deploy these technologies and create what will be almost universal connectivity, not just for ourselves, but billions of IoT devices, we have to decide and make hard decisions about what kind of cyberspace we're creating. We can continue to try to create a cyberspace that reflects our values. Authoritarian countries are trying to create a different kind of cyberspace that reflects a different governance model. And we have to be clear that that's not what we want and work with our allies to keep it from happening. And if we use our economic power and we use our power of technology and innovation, that we can pretty much get what we want. And the last point is, whatever we do, we need to find a way, and I'm not talking about the government owning infrastructure, the last thing I want to see, but to close that gap for people, the roughly, 18 million people or so in this country who just don't have connectivity, either because they can't afford it or they don't know how to use it or they don't want it or it's just not available to them because they live in areas where there isn't enough, demand density. And we've got to find a way to close that gap, because if we don't, those people will become even more marginalized in future than they are now. And as we talk about a permanent underclass, that'll become a new permanent underclass, and it's inexcusable. So those are my sort of closing comments.
Thanks, Sam. Anyone else? Closing, Milo?
Yeah, I would just say it's important to recognize that U.S. companies exist for the benefit of their shareholders. It's not fair to layer on them the job of fixing a national security problem or generating infrastructure that is an example for other companies to follow. They exist to maximize profits. And, U.S. telcos are generally much more profitable than their overseas competitors. That's why you don't see them buying a lot of overseas companies the way you see rest of the world folks do that. Cable operators are again, they're doing what they should do. And if you've got a problem, whether it's building out in rural areas, and what is the benchmark for what speed needs to be, right? What is competitive? There was a time when people thought 3 megabits was competitive, but in the era of Zoom and remote work, that's not competitive anymore, right? That's not meeting the need. And so these standards are constantly changing. So I think the question is, what incentives do you provide to private industry? And I agree, a government-owned apparatus is unlikely to get you an outcome. But how do you switch incentives so that businesses, whether it's an accounting changes or reducing barriers to deployment, or just getting the federal government to be coherent about policy, dig once, one touch make ready, right-of-way access, a whole set of things. If we don't do that, more spectrum available, we're not going to, failure is an option. And we're not on a good path right now to have a country that we have everybody connected and everybody able to enjoy the benefits of what modern technology can provide. And other countries will supplant us. Success is not guaranteed here.
Thanks, Milo. Michelle, any closing thoughts? Okay.
Yeah, no, not really. I've really learned a great deal because I'm not an engineer. So it was very nice to hear all of your thoughts and ideas. So thank you.
Thanks. Well, thanks so much, everyone. Have a lovely evening, and thanks for joining us at Mitre. And thanks.
All right. Well, thanks to the panelists. I think this was a great session. Also, just FYI, Mitre is hiring. So if you want to come work on these problems at Mitre, go to our website, and there's a whole bunch of different job recs in this area. So we'll look at this, recruiting help at mitre.org. So yeah, please reach out. And again, this is a topic of utmost national importance. I mean, our sponsors are across the federal government are of course keenly interested in it. And again, so thank you all for the excellent discussion. And I guess we have our next one of these seminars coming up on March 11th, focused in the healthcare space. Details to follow, but look forward to an exciting discussion on that area as well. Thanks. Bye.